Hello everyone, my name is Chandana and I'm excited to present our final project, House Prices Advanced Regression Techniques. Coming to introduction slide. In this project, we focused on predicting house sale prices using advanced data sciences and machine learning methods based on Ames Housing Dataset. Our main objective is we understand the data, interpret the results, and explore patterns using both a supervised and unsupervised methods, like generating insights that could be useful in real world housing applications. Coming to next slide, dataset overview. In this, 1500 property records and 80 features, both numerical and categorical. This made the analysis both interesting and challenging. We encountered several data quality issues like missing values, which had the address carefully before modeling. Coming to next slide, methodology overview. In our project, we followed systematic pipeline. Firstly, we loaded and explored the data and cleaning and imputing missing values and conducting both visual and statistical analysis to understand relationships. We had applied future engineering and transformations to reduce skewness and improve model performance. To address the high, we used PCA for dimensionally reduction. Next, we implemented clustering techniques to uncover patterns and segment the housing market in similar groups. For predictive modelings, we tried several algorithms, including linear models and ensemble methods, and we used Lime and feature importance plots to make our models unpredictable and explainable. Next, my friend will be continuing.
Hello everyone, this is Saikiran Chidurala. I'm going to explain about the key techniques we applied in this project. We started with visualization tools like Plotty, Seaborn, Matplot library to explore the data, identify patterns and the trends. For pre-processing, we handled missing values, corrected skewed numerical features, and applied one hotshot encoding for categorical variables. Next, moving to the modeling side, we tested several powerful machine learning models, including random forest, XGBoost, SVR, and ElasticNet. To improve performance, we use stocking, which combines the strengths of multiple models. Now, finally, we evaluated our models using key metrics like mean square, error, and R square, and the cross validation to ensure reliable results. Moving to the next slide is a model performance summary. This slide gives a summary of our model performances, and the main point here is that the no single model is clear winner, but by combining models through stocking, we achieve the best results. And we focused on minimizing predictions, errors, and maximizing R square, which helped explain more variance in house prices. Overall, stocking models gave us stronger and more consistent predictions compared to using single individual algorithms. Finally, now let's look at how the models perform by clustering results. We use it to segment the housing market into the four meaningful groups. First one is affordable homes, second one is mid-tier houses, third one is premium houses, and the last one is luxury properties. Among the methods we tried, K-means performed the best, achieving a score around 0.28. Clustering was slightly lower, and the DBSCAN didn't work well due to the uneven density in the data. This clustering approach gave us the valuable insights, helping us to understand patterns across the different market segments and offering more targeted recommendations. To wrap up, these combined techniques not only boosted our model accuracy but also provided meaningful insights into the housing market, making our analysis both practical and actionable. Next slide, you will continue by Srilakshmi. Thank you.
Thank you, Saikiran. I am Srilakshmi Kottapalli. Now I'm going to explain about key insights. Here, first one is trip data. Chart icon captures information on trip duration, distance, routes taken, and driving patterns. Useful for analyzing driving efficiency and behavior. Next one is location data. It is a house icon, uses GPS to track the real-time and historical location of vehicles, supports route optimization and asset tracking, vehicle data. Car icon, that is collects vehicle specific metrics such as speed, fuel level, engine status, and maintenance alerts. Helps in diagnostics and vehicle performance monitoring. Next one is user data. People icon stores data related to the driver or user, including identity, driving history, and user specific behavior. Enables personalization and accountability in vehicle usage. Next slide, please. Here we are going to discuss about visual highlights. Correlation heat map for numeric features and price visualizes how strongly each variable correlates with price. Helps identify inflation numeric features. The next one is PCA 3D scatter plot. Uses principal component analysis to reduce dimensionality. Illustrates clusters or groupings in the data, example by user type, vehicle model, etc. Next one is violent plots, shows the distribution of price across categories, example fuel type and region. Combines box plot and KDE for richer insights. Feature importance plot from random forest highlights the most impactful features used by the model. Useful for feature selection and model tuning. Next one is lime explanation for one prediction explains how specific features influenced an individual prediction. Great for transparency and building trust in model outcomes. Next slide, please. Here we are going to discuss about data quality and missing values. Here we have three types. It's a mean imputation, median imputation, mode imputation, and predictive imputation. First, we are going to discuss about mean and median imputation. Here, it's a imputation replaces missing values with the mean average of the non-missing values in the column. Pros are simple and fast, and cons are can distort data distribution, especially if there are outliers. Median imputation replaces missing values with the middle value of the column. Pros are more robust to outliers than mean imputation. Cons are still ignores potential relationships with other features. Mode imputation. Mode imputation replaces missing values with the most frequent value mode in a column. It's particularly useful for categorical data, though it can also be applied to numerical columns with the repeated values. The pros are good for categorical data with dominant classes. Cons are can create bias of if the most frequent value in overrepresented. Coming to predictive imputation, predictive imputation involves using a machine learning model to predict missing values based on other available features in the dataset. Unlike mean, median, or mode imputation, this method leverages patterns and relationships between variables for more informed estimations. In this, we're having steps like separate the data set into rows where the target column with missing values is not null, used for training. Rows where the target column is null, used for prediction. Predict missing values using the trained model. Thank you. Next, my friend Adinara Reddy will continue.
Thank you, Srilakshmi. My name is Adinarayana. Skewness and log transformation. Skewed data can negatively affect regression models, leading to poor performance. A common solution is applying a log transformation to normalize the distribution of skewed data, reducing skewness and improving model predictions. For this, before versus after. Prior to transformation, features like geolive area may have a right skewed distribution. Applying a log transformation can make the distribution more symmetric, helping improve linear model performance. Next slide, please. Correlation heat map. Correlation analysis helps identify relationship between the variables and detect multicollinearity. High correlation between independent variables. Multicollinearity can be lead to overfitting and instability in regression models. By focusing on features most correlated with the target variables, like a sales price, future selection can be optimized. For this one, to approach, calculate the Pearson correlation coefficient between numeric features and a sale price. Focus on the top features most correlated with the target, which can help in the future selection and reduce redundant information. Next slide, please. Outlier detection. For the outliers are the extreme values that can distort regression models predictions. Identifying and removing outliers ensures more accurate and model results. For this one, we have two methods, G-score and IQR. For the G-score, values more than 3 standard deviations away from the mean are considered outliers. For the IQR stands for the interquartile range. But outliers are identified as values outside the range defined by 1.5 times the AQR. And next, my friend Manikumar will be explaining.
Thanks, Adi. So my name is Manikumar. So I'm gonna give the explanation for the clustering for neighborhood segmentation. So in the neighborhood, significantly most affects the house prices due to multiple factors, moreover like location, amenities, like local economy and everything. So by using this clustering, so we're gonna make the similar neighborhoods together and make the models to capture more better patterns within the group of neighborhoods. And also it's going to be improve the prediction accuracy. For this, we are using the approach like dimensionality reduction techniques, which is more like PCA, which is can be used to simplify features, and it also followed by the clustering methods like k-means to the group of similar neighborhoods. For this, with the help of this approach, we can be highlighted neighborhood patterns, which can be easily directly influence the house prices. Coming to the next slide. So from this, we're gonna give the future engineering example. So within this, we're gonna involve in creation of the new features, which is from the existing ones, which can be helpful to improve our model performance further. For this, we're gonna derive features which can be provide additional insights and also going to be highlight like a hidden relationship between the variables too. For this, here we have the couple of examples, which one is like total ASF, like the Srilakshmi already explained about this. So this we can have the total square footage of the house. For this, we're gonna combine the areas like the basement and floors, like the example, like we use the parameters names like BS and T, fine SF1 and 2, and the give like the ground floor level area and the total rooms observed thing. So with the help of this, we're going to calculate the total square footage of the house. Coming to the next one is like age of house. So it can be calculated by using the difference between the year of sold and the year of built. Like this, we have the future engineering examples in our project. Coming to the next slide. Now here is that model evaluation strategies that we used. So in this, we use the cross validation, which is most effective way to estimate our model performance by rotating the training and testing sets. With this, we're gonna reduce the likelihood of the overfitting and provides a more robust performance estimations. For this, we use the approach as like moreover for the k-fold cross validation. So for this, we're gonna make the data set split into like k subsets, and the model was going to be trained and validated k times. In the each time, we're gonna use a different fold as the validation set to get the output as like to get this evolution strategy applicable. with the help of this, we're going to ensure that our model performance is going to be well across in different subsets of the data. Coming to the next slide. Model interpretivity. With this, in this, we consider that a shapely additive explanation. So, which is a method that explains model predictions by showing the most contribution of each feature to the final predictions. So, with the help of this, we're going to make a complex models which going to be more interpretable by indicating that which more features have the most significant impact on our model's output. For this, we use the approach like we're going to highlight the importance of each feature by showing whether it's going to be like push the prediction higher or lower, which going to be allow for a clearer understanding of how specific features affects our model outcomes. The next slides is going to be explained by my teammate Ravi Teja.
Thank you, Manikumar. My name is Teja Tiruveedhula. Here I am going to explain about challenges and limitations. Let me start with some of the key challenges and limitations we faced during this project. First, the dataset had a large number of categorical features, which after encoding significantly increased dimensionality. This made modeling more complex and required careful future solution. And we also encountered missing niche features like a pull-lag and miss feature, which had a high missing ratios. While we imputed or dropped some of them, their absence may have affected prediction accuracy, especially in high-end properties. Another challenges was the DBSCAN clustering underperformed due to issues with the feature scaling and density variation. Unlike K-means, DBSCAN assumes uniform density, which was not the case here. Finally, setting up Lime for model interpretability was a bit challenging. It required GPU dependency and custom installation steps, which could be a barrier in some environments. Could you please move to next slide, please? Here I am going to explain about recommendation. Based upon our analysis, we have a few practical recommendations for different stakeholders. For real estate firms, we suggest using key features like a total SF, overall qual, and our engineering garage score in their pricing models as they were consistently among the top predictors. To better understand their customers, agencies could also segment clients using the clustering insights we discovered. This would help them tailor offerings to different budget ranges or home preferences. For home buyers, especially those on your budgets, we recommend focusing on mid-tier homes located in high-quality neighborhoods. This property showed high value for money based on our cluster and price analysis. Could you please move to next slide, please? Here I am going to discuss about future work. Looking ahead, there are several areas we would like to explore to enhance this project. First, we aim to expand the data set by adding external data like school ratings, crime rates, or access to public transport, which are going to influence house prices. We also plan to explore deep learning models such as fully connected neural networks or AutoML tools. This may yield better performance, especially on large data sets. Another future goal is to build web dashboards that presents model insight clusters and price predictions in an interactive format, making it more accessible to non-technical users. Could you please move to next slide, please? Here I am going to discuss about conclusion. To conclude our project successfully, combine machine learning, clustering, and interpretability techniques to predict house prices with a high accuracy and actionable insight. We cleaned and transformed a complex database, engineered new features, and applied multiple models, including random forest, XGBoost, SVR, and ElasticNet. We then combined them using stacking for improved performance. Our clustering work allowed us to identify for distinct market segments, providing useful segmentation insights and tools like a Lime and Shape, enhanced model transparency, which is crucial in real estate application. Overall, this project not only met its technical goals, but also demonstrated strong potential for real-world impact in property evaluation and real estate decision making. Thank you for giving this opportunity.